So in this video, I'm going to discuss the tiered apart problem which occurred in today's CODEFORCES educational round challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem is states that you're given a string and you can delete elements which are not adjacent. Okay, and you have to delete them in such a pattern such that after performing this operation over the string for some number of times, all the elements of the string becomes equal. Okay, and you have to find out the minimum number of times you have to perform this. So for this a b a c a b a, you can choose b and c since both are non-adjacent, and then you can choose b because these are also non-adjacent. So if we delete them, so the string becomes a, right? So how many times did we need to traverse it? We needed to traverse it one time. For this CODEFORCES this thing, so we can delete C, then D, then F, then R, then E, right? And in the next round we can delete E and then C. Remember one thing, since I have deleted this, so C and S now are adjacent. Okay, like let me do it. So let's say code 4 says, okay, so I was deleting C, D, F, R, E. So now it becomes O, E, O, C, S. So now I am deleting E and C. Now it becomes O, O, S. Now I am deleting S. So how many times did we need to perform it? Now it becomes O. Okay, so O works because all of the elements are equal. So how many times did we need to do this? 1, 2, 3. So that is 3. For this it was 1. For this all the elements are equal, so it is 0. For this it is 2. I will tell you why. So now the basic approach is to do this, like perform these operations, but that is a very naive approach and that is going to give you a TLE. So we know that this is going to give you a TLE. So what is the most probable solution? It is you have to check for all the elements, since it is given that the elements of the string are ranges from A to Z or Z as you may say. So since this thing ranges from A to Z, so what you have to do is you have to check for all the elements from A to Z. Okay, A to Z, and you have to try to make all the elements of that array of the string as CH. Okay, let's say first of all we are going to check how many times do we need to do this deletion so that all the element becomes A. How many times do we need to do that operation so that the element becomes B, so that the element becomes C. Okay, I hope you get it. So this is a loop. Okay, this is a loop. This is the outer loop. And for every possible, that is, if it is A, I have to make the string in the form A. Okay, in this one. If it is B, then I have to make the string in the form B. Okay, like if it is C, I have to make it C. If it is D, I have to make it D. So this is what I mean. Okay, so you have to try doing this for all the elements, and whatever gives you the minimum result, whatever gives you the optimal solution, you have to consider that. So this is a naive approach. Okay, this is the naive approach. So this you can do by yourself. But the thing is that this operation thing, how many times do we need to? This is about choosing which element I would not prefer to delete. Okay, for this case we were keeping the O's. That is, I am not going to prefer to delete O. So if CH is O, then this thing works optimally. Okay. Now the thing is that for every element you have to find out what is the distance. Okay, what is the distance, what is the maximum length of the string which doesn't consist of that element. For let's say for this CODEFORCES thing, for says, so this string doesn't contain O, this string doesn't contain O, and this string doesn't contain O. So what is the maximum among this? This is of length 1, this is of length 3, this is of length 4. So maximum is 4, right? So let's say this 4 is distance. Okay, I am giving it the name distance. So for this, what would be the distance for A, B, A, C, A, B, A? The distance will be 1, 1, 1. So what is the maximum? It is 1, right? So distance is 1, and for this the distance is 4. Now once we get the distance, now we can focus on how to get the solution. Okay, so what is, like, let's get into this problem. So let's say your phone numbers. Okay, so let's say your phone numbers x, y, z. Let's not say x, y, z, let's say a, b, c, d. Okay, these are 4 alphabets, so you have to delete them. So what you can do, you can delete a and c, then it becomes b, d. Then you can delete b, so it becomes d. Then you can delete d. So how many operations for 4? It is 3, right? So see, if distance is 4, the answer is 3. But how to solve this? Okay, the question is how to solve this. So if you watch this thing very minutely, you will get to know one thing, that if there are n number of characters, so after deletion we can delete n by 2. Okay, n by 2 characters at a time, because you can select alternative positions, so that is n by 2. So what is the recursive relation? T of n is equal to 1 plus t of n by 2. So if you go on following this, and t of 1 is equal to 1, okay, t of 1 is equal to 1. So if you follow this recursive relation, so you will go to the solution. So now let's do one thing. We will check for a, b, c, d, e, f. So this is a very nice condition. So I think this page is completely filled up. So I'm going to use the sort the subarray problems page. So let's say this is a, b, c, d, e, f, right? So if I consider a, what is the distance? 1, 2, 3, 4, 5, right? Distance is 5. If I consider b, what is the distance? 1, 2, 3, 4, right? The distance becomes lesser, so I am going to consider this. I have to consider the distance where it is minimum. Okay, remember one thing. So for C, what is the distance? This is 3 and this is 2. So what is maximum? That is 3. And is it lesser than this? Yeah, it is lesser than this. For D, ABC is length 3 and EF is length 2. What is maximum? 3. Is 3 lesser than 3? No. For every other element, so this is the minimum. Okay, the distance of 3 is the minimum. That is, we have to, if we consider C, then this becomes distance 2 and this becomes DEF becomes distance 3, and this is the minimum of maximums. So for T of 3, we have to find of T of 3. Okay, so what is T of 3? T of 3 is T of 3 by 2. Okay, 1 plus T of 3 by 2, and T of 3 by 2 is T of 1. Okay, T of 1, because 3 by 2 is 1. And what is T of 1? T of 1 is, as I told, T of 1 is 1. So that is 1 plus 1. So what is 1 plus 1? That is 2. So see, the answer is over here, it is 2. And the last answer is 4. So like, if you check out, if you do this, so you will get to know. So this answer comes as 4. So this is how the code works, like not the code, the logic works. So I think this is a little bit complex, but if you get it, that is very nice. So that's it. Thank you.